Okay, let's take a look at the last few questions. Now, this is just the compound interest formula, okay? So it looks like, and this is what it means, initially we had $4,000 in the account. That is what that is, P, the principal, okay? The interest rate is, this is in decimal, so this is 3.5%. You just have to look at the compound interest formula. How much money is in the account after 6 years? Well, you just plug 6 into there and put it in your calculator, okay? By the way, don't forget the 12 means it's being compounded monthly. So that last question is just put in your calculator. Now, for these kind of questions, this just means if x is 5, what's the answer? In other words, 3, 2 minus, what's 3 times 5? 15. What's 3 to the power negative 13? I just have to put that in my calculator. That's all those questions are. Question 10 on this one. Okay, so if we think it now then, so for exponential growth, we tend to use this equation here. The future amount is the initial amount. The base is the exponential e, okay, which is about 2.718. You can look into e, Euler's number. It's like pi, transcendental numbers, one of those magical numbers like pi and e, all right? Now then, if the rate is 5%, okay, well actually I'm just going to write this first, okay, to the kt. K is the growth rate. Sometimes you might see different numbers. You might see r there for interest rate or growth rate. So, and t is time, okay, so a is subscript 0, that's the initial amount, e to the kt, okay? So the initial amount is 687, so here is my function. 687 is the initial amount. Here's e, you'll see it on your calculators. The growth rate is 5%, remember? So I'm going to write that as 0.05 t. That's all it's asking for, okay? That's that, the initial amount and the growth rate. If it's decay, that will be a negative. Okay, so let's have a look. If it wants to know, so on a further question, like say in 10 years' time, how many foxes are there? You would just put 10 there and put it in your calculator, okay?